over the study guides for today that I asked you to work on Tuesday, and make sure you understand the basic ideas. So most importantly here, I want you to make sure that you understand what a central angle is. So the central angles have their vertices at the center, and the central angles measurement is the same as the measurement of the arc that is across from it. So NP here at the very bottom has a measure of 40. So from M to P, that measure is 90. And then from Q to M to N, that's literally telling you start at Q, trace over M, and stop at N. So starting at Q, tracing over the M, and stopping at N, the sum of all of those arcs is 50 plus 130 plus 50. That makes 230 degrees. So on the back side, there are just some basic ideas I wanted to summarize, and they're all underlined, but what's the key on the back side is all of these relationships, even though we're working in circles, we're really just using congruent triangles. So this is what your figure should have looked like if you drew and labeled everything carefully. So a radius like AD, which is drawn perpendicularly, so if it makes a right angle with the chord, it bisects that chord. So literally, because I've got right angles between this radius and the chord, I know that chord is cut into two equal parts. That's one idea that's really important. The second idea that I wanted you to see is that chords that are the same distance from the center, they're congruent. So these chords, BC right here and GF right here, they're both 16 units long because they're both the same distance from the center. They're both 15 units from the center. And the last idea, I wanted you to see that chords that are congruent, they lop off, they cut off arcs that are congruent. So notice this chord BC is congruent to the chord GF. So the arcs here from B to C and from G to F, those arcs also have to have the same measure. And they do have the same measure using some trigonometry. They're both about 56 degrees. And they're congruent because they are arcs that are together. They have the same measure and they're together in the same circle. That makes them congruent. The idea of this part at the bottom was to recognize that if circles have different radii, then even arcs with the same measure can have different lengths. So both the arc NL and PM, they're both 90-degree arcs. They have the same measure, but they are not congruent because they are in circles with different circumferences. They are in circles that have different length radii. So those were the main ideas from the study guide that I wanted you to be comfortable with. If you want to look at the study guide in more detail, you're welcome to look at the one I posted at the front board. So period 2, you already have this handout, and hopefully you've had a chance to start working on questions 1 to 13 to practice those study guide ideas. So period 5, you're going to get this handout today, and in class you can work on questions 1 to 13. What I want to do briefly, though, is a few examples to show you how you can complete this and do questions 14, 15, and 16. So that involves looking at these examples, tangents to circles. So first of all, we got to figure out what we mean by a tangent. So a tangent to a circle. So I'll draw a circle here. Here's the center of the circle. A tangent to a circle is a line which intersects the circle at exactly one point. It's a line that intersects the circle at exactly one point. So literally, here's an example of a tangent. It touches the circle at exactly one point, and that's it. So the difference between a tangent and a secant to a circle is a line which intersects the circle twice. So here's an example of a tangent. This line is a tangent. It cuts through the circle twice, and it actually contains a chord. So right here we have a chord of a circle, the segment where the endpoints of that segment are on the circle. So the one thing that's special about tangents, which we can prove indirectly, if we have some time, we'll do that in class. So A line is tangent to a circle if and only if something special happens when you draw the radius to that point of tangency. You get a right angle. Those are perpendicular. So a line is tangent to a circle if and only if the line is perpendicular to the radius. So the radius drawn to that intersection point makes a right angle. So the radius drawn to the point of tangency forms a right angle. So they have to be perpendicular. So what does that mean? What that means is we can get all kinds of crazy things like congruent triangles. We can get right triangles. So take a look. Here, solve for x to the nearest tenth if BC is a tangent. Okay, so first of all, solve for x to the nearest tenth if BC is a tangent. So we are assuming that BC is a tangent. So that means we've got a right angle here. So you're going to recognize this in just a second, but we can use the Pythagorean Theorem. So here's the legs. So x squared and 12 squared, those have to equal this quantity, x plus 8 squared. So something nice is about to happen, though, and then you're going to recognize the pattern. So this is x squared plus 144. And if you FOIL this, so remember, x plus 8, the quantity squared, is really the quantity x plus 8 times the quantity x plus 8. So x times x makes x squared as you FOIL. The outside and the inside terms both make 8x, so that's a total of 16x. And the 8 times the 8 makes 64. And notice that what happens, you end up with an x squared on both sides of the equation. So you can subtract x squared from both sides and it's gone. So now if you subtract the 64 from both sides of the equation, 144 minus 64 gives you 80. And now you can divide by 16. And we didn't have to worry about tenths because we didn't have to round to the nearest tenth because 80 divided by 16 makes 5. So maybe you'll recognize this. X is 5. Right triangle, 5, 12. If this is 5, the hypotenuse is 13. That's a 5, 12, 13 Pythagorean triple. And we can use Pythagorean triples then to help us decide if we have a tangent segment. So here is the segment BD, its length is 24, and I'm trying to decide if it's tangent to the circle at B. Well, take a look. The radius is 10, so that means this length is 10. And this side right here is 26. Well, I hope you recognize this. This is a 5, 12, 13 Pythagorean triple. That's been doubled. 10 is 2 times 5. 24 is 2 times 12. 26 is 2 times 13. So that satisfies the Pythagorean theorem. That makes this a right angle. So that means that BD really is a tangent. That's true. We can explain that using our right triangles and our triples. So here's example 3. In example 3, we're going to assume that BC is a tangent, and we're going to assume that CD is a tangent. And then we want to find the measure of this angle here. Well, in my opinion, guys, make triangles. Look, drawing the segment from C to A. Now you have 2 right triangles. And I know they're congruent triangles because the radii are congruent and they share the hypotenuse. These triangles are congruent by what we called HL, hypotenuse leg in geometry 1. So this 140 has to be split into 70 and 70. And now that tells me this angle, 90 and 70 makes 160. That means that to make 180 degrees, this has to be a 20-degree angle. And if they're congruent triangles, this one's a 20-degree angle also. So the measure of angle C is 40. So congruent triangles and right triangles, they just won't go away. So last, in example 4, if we assume that DC and FB, if we assume that all of these that look tangent, if we assume that these are tangent, let's find the length of x. Okay, well, same thing. Look, I could draw in radii from C to A and from C to E, and I could make congruent triangles. I mean, you don't have to do all of the drawing if you don't want to, but these are right angles, the radii are congruent, the hypotenuses are congruent. My point is, if D to C is 10, so D to this point of tangency, D to E is also 10. Well, look, we could come over here, we could draw the triangles and use the congruent triangles and do exactly the same thing over here, or we could just recognize that we could do that. And this length from B to F is 4, so the length from E to F, it also has to be 4, and 10 plus 4 makes 14. And we're done. So even though we're working with circles, the ideas of the right triangles and the congruent triangles that we've been using all throughout geometry, they still apply.